Okay, so the next problem in the lead code we are solving is successful pairs of spells and potions. Okay, so basically here will be given the list of spells and list of potions and one success value. Okay, so what does it mean is, let's say that our spells are like this. Okay, so if we multiply this, we'll get one number, correct? Will if each of them, okay, 5 into 1, 5 into 2, 5 into 3, 5 into 4, 5 into 5. Okay, so if you multiply, we will get one number. So you will be marked as whenever the spell and the potions that matches, like I mean whenever we multiply it, and if the number is greater than or equal to success, at least success, right? If it is like a kind of victory kind of thing. Okay, so what we'll have to do is we'll have to find out those pairs that will result in a victory. Okay, 5 into 1 will result in 5, which is not greater than or equal to 7, right? So it is not it's not a good pair for us. Okay, so 5 into 2, 10. That's a good pair, correct? That is greater than or equal to 7. Similarly, that has been explained here already. So 5 and 3, if we do that thing, right, finally we'll be getting this calculation. Let's say that if I multiply 5 to all of this, right, we'll get this answer. And we obviously know these are the good ones. So obviously, so answer is 4 pairs for this one, for number 5. Okay, we'll be adding it to the list, and finally then we'll be doing the same thing with against this one. If you multiply one with any of these numbers, obviously as all the numbers are less than 7, right, so we'll not getting any of the successful pairs, we'll have to add a 0 to it. Similarly this one. Okay, so now what we're trying to do here is, this is the problem. Okay, this is the problem. So now what we're trying to do here is, we will have to, like I mean we are trying to do it every multiplication and everything, right? It will be like of n square time complexity. So to avoid it, what we can do is, we know, let's say that let's say if this is already in a sorted order. Okay, let's say if that is already in sorted order, and I multiplied this one. Okay, 5 into 2, 10. Okay, and I can simply say that all the rest of the elements is also greater than the is a valid pair, correct? Because we know that it's always the greater number one, correct? If 5 into 2 itself is greater than the 7, obviously whatever the number that is greater than that will also give us the value that is greater than that, correct? Like that will all will be the valid ones. So what we'll do is, we'll first identify what is that number. Okay, what is that location? Okay, that index that will give us the success result. Okay, so once we get that, we can just say that total length minus that, and we'll get this length into that will be the number of pairs. Okay, so here also we found that 2 is the thing, right? So what we'll do is, length is 5 minus 1, like I mean index will be 0 1, right? So just to be clear, in the while solving on the problem also, 0 1. So index is 1 and total is 5 minus 1 is 4. So 4 is the pair that we are going to get. So similarly here, we'll get a length is 5, and index is also pointing at 5, because we are when we run out, right? So 5 minus 5 is 0. So similarly here also it will work it that way only. So we'll have to append it, and finally may I send it as a total number of pairs. It's a list. Okay, so how to approach this problem? So whenever we hear the term sorted, right, like if sorting doesn't matter here, like in the given input, if even though if we sort it, if it does not affect the output, right, we'll have to go with the binary search whenever it is sorted, and if we are looking for some element. But here it's not that we are directly looking for an element. It's not that we don't know if it is a 2, like, because whenever we multiply, it say that to get 7, what is the thing that I should get? I think 1.25, right? 1.25 something I need to get the number value greater than 7, correct? So but I'm not looking for exactly 2, I am looking for a number that is greater than or equal to 1.25. Okay, so that's the one thing, that is the one new thing that I learned here. So usually whenever I thought was, when we can use binary searches, like if you want to look for an element, you can just simply use the binary search, but you can tweak the binary search such a way that you can have your own condition. So here what is the condition? It should be greater than or equal to that whatever the success, right? Once you multiply, it should be success. Okay, that is the thing. Okay, so now let's see, what we'll do is, for each thing we'll have to do that thing, right? First we'll sort it. Okay, first we'll sort this. Okay, and for each of the spells we'll do the calculation, like I mean we'll find out the good pairs that will result in the value that is at least 7. Okay, so what we'll do is, so we enter the spell. So let's pick 5 first. Okay, and now we'll apply the binary search such that we'll multiply this, and we'll have to get the number greater than 7. Okay, so binary search, yeah, it's we should be knowing already this, like how the binary search work on left and right pointer. Okay, so while left is right and right, okay, that is our base condition. Okay, and we'll be going to the middle index. Okay, and then we'll check if that is greater than or equal to our success value or not. So whatever the value, let's say that 1 2 3 4 5, this is already sorted. This will make our task easier to explain. So 5, right? So our left pointer was here, right pointer is here. Okay, and we'll the middle index would go here. Okay, and what is this value? It is a 3. 5 into 3, 15. It is greater than or equal to success, correct? That's a good thing. Like, I mean, we found some value, that's a successful pair. Okay, but there is a chances that there might be already a previous one, right? We need a first index, not the index that we have, any index. We need the first index, right? So what we'll do is, if this is a found, obviously there might be a chance that the previous one might be also, right? So what we'll do is, we'll move our right pointer to the mid minus one. So we'll do the next calculation in this range. So let's say that again, what will happen? 5 into or will, if we take the this, right, if we take the mid and everything, will come here. 5 into 1, that is lesser, so we'll move our left pointer to back to this. So at when we do at this condition, left and right pointer will be, both will be at the same location, and if we do the calculation, it will be greater than 5 into 2 greater than 10. So that will be returning as the, like, I mean, we'll get a index where actually we are looking for, right? So we'll be found an index that matches this condition. Okay, like, I mean, wherever it is greater than, product is greater than this. Okay, so and at the end, once we know the index, left and right pointer are both pointing to this. Okay, so we can pick the left index, and we can find out a difference, like how many from this is the index. We know, we identified that 2 is the starting node. Okay, so we can identify the remaining length and add it to the pairs. Similarly, we'll be iterating again and again. To summarize, here, so we have a spells, we have portions, we have a success rate. Okay, and we got to know that reordering or sorting these portions will not affect our result. Okay, once we got to know that sorting it doesn't affect, and if you are looking for some element, we can go with the binary search. Okay, and binary search is not only for, like, you can just directly search for an element, but also you can write your custom logic. You can tweak the binary search such a way that to look for an element, even if to identify if there is a number greater than or something. Okay, these kind of conditions can also be used in a binary search. By that way, we will be identifying a number that is, like, I mean, that is the minimum number that is required to get the success pair. Okay, so once we get that, we'll find out of total length, we'll subtract this so that we can get this length, and that length is the, like, I mean, maximum number of pairs we will get. We'll add it to the result. That's it. Thanks.